Find the full solution to this set. Well, it looks like none of these are going to be really easy to reduce. But this, if I multiply by a negative, will end up becoming opposite. So I'm going to actually multiply this by a -1. And if I do that, I end up getting negative 2x minus 3y plus 3y plus 2z equals -5. And then I'm going to just bring this over. I'm not going to do anything to it. Plus 6z equals 7. Now, if I add these, I end up getting 2x minus 2x is just going to go away. Then I get a 2y here. And then plus 8z equals 2. All right, well, I got to get rid of x again. So what I'm going to do is I'm going to multiply this by a -2. So I get negative 2x plus 4y minus 2z equals -6. Now, I did that mainly because I haven't used this equation yet, so I have to use him, and it'd be easy to just reduce those ones. And I got to reduce x again. So if I add those together, this goes away. The x goes away. And then negative 3y plus 4y is just y. And then minus 4z equals -1. So what I'm going to do next is I'm going to multiply this by 2. That way I can get rid of my y's. So 2y plus 8z equals -2. And if you notice here, you end up getting, minus 8z. 0, 0, 0. So 0 equals 0, which means it's not inconsistent. There is a solution, but there's going to be a ton of solutions. And if you remember, the solution is going to look something like this. This is going to be, I'm going to choose a z to be whatever, and then I need to find x and y in terms of z. So if I want to find y in terms of z, all I need to do is solve this for y. And if I do that, I end up getting y equals 4z minus 1. Now, if I choose any number z, in other words, t, if I pick some number t to be in place of z, so I put t in place of z, y is going to end up being this. So it's going to be 4t minus 1. Then I need to find x in terms of z. Now, the problem with that is I got rid of x from the very beginning. So what I'm going to have to do is I'm going to have to start over. This time, instead of eliminating x, I'm going to eliminate something else. So if I want x in terms of z, I need to eliminate y. So what I'm going to do is I'm going to eliminate y, and I only need to do it once. I don't have to do it twice. So I'm going to multiply this by 3, and I'm going to multiply this function, this equation, by -2. That way, 3 times -2 is -6, and -2 times -3 is +6, and so they'll be opposites to each other, and it'll work itself out. So I end up getting 3x minus 6y plus 3z equals 9. And then I have -4x plus 6y plus 4z, and that equals -10. Now I'm going to add them. So this will give me -x plus 7z equals -1. Now I want x in terms of z, so I need to solve for x. So I get -x equals -7z minus 1. Divide everybody by a negative, and x equals 7z plus 1. Now, I'm going to pick a number t, any number t, and I'm going to put it in for z, and that will give me an x. So, if I do that, x will look like 7t plus 1. So this is my answer. Now, what does it mean? Once again, I can plug in anything in for t. So I'm going to plug in, let's say 0. So if I plug in 0 in for t, then I'm going to plug 0 into this one and then into this one. So 7 times 0 is 0, plus 1 is 1. So x is going to be 1. And then I plug 0 into here, and that'll give me -1. So one correct answer is actually 1, -1, 0. And if I plug this into this, it will work. Then let's say I want to find another solution. Well, another solution could be 1, if I choose t to be 1. And then if I plug it into the other one, 7 times 1 plus 1 is 8. 4 times 1 minus 1 is 3. So another solution would be 8, 3, 1. And if I could just keep going and going and going on all of these, and I can find an infinite amount of solutions by picking a t and then plugging that t into these two, and you can get all three numbers that will all work for this solution. So there are many solutions to this equation. To this system.